Right, chapter 3, representations of data. First section, 3.1, outliers. You need to know what an outlier is. So when we're talking about data and we talk about values that are outliers, you need to know exactly what we're talking about. So please fill in the gap in your notes. An outlier is an extreme value which lies outside the overall pattern of the data. So it seems to stick out from the rest of the data. It's either unusually high or unusually low. So pause the video for a moment and get that definition into your notes. Now there are ways of calculating which values qualify as outliers, and a common definition of an outlier is any value that is either greater than the upper quartile plus some number times the interquartile range, or less than the lower quartile take away some number times the interquartile range. And note that in the exam you will be given the method to identify an outlier. So they will say something like, using the following definition, it could be Q3 plus 1.5 times the interquartile range, so K might be 1.5. You then got to go ahead and work out the outliers. This is not the only way of working out outliers. It could be anything. So you could be given any calculation and be expected to run with it, use it to find the outliers. Sometimes outliers really are legitimate values. What you mustn't do is, if we identify an outlier, get rid of it straight away. We don't do that. There are times when an outlier should be removed from the data. That's if we discover that it was an error. So that should definitely be removed from the data. However, strange values happen all the time. So just because something's an outlier doesn't mean you should get rid of it. In general, we do not get rid of outliers unless it's proved or shown that it was actually caused by an error. When we do recognize it as being from an error, then these data values are called anomalies. ANOMALIES, anomalies. Now you cannot remove data to make it fit a pattern. That is not how statistics works. That's not how science works. You must always be able to justify why a value is removed. So if you discover that the person doing the reading made a mistake, or if you discover the machinery doing the experiment was faulty for a particular value, then that is a legitimate reason for removing them. Right, I'm going to move on to example 3.1.1 now. So here it is, example 3.1.1. The blood glucose of 30 females is recorded. You don't need to know what blood glucose means or what it is. And the results in this measurement here, you don't need to understand what that measurement means either, but the 30 results are shown below. At a quick glance, they do seem to be in ascending order, which could be useful. An outlier is an observation that falls either 1.5 interquartile range above the upper quartile or 1.5 interquartile range below the lower quartile. So here this question has told us the way to figure out any outliers here. So in other words, in this question, K is 1.5. Part A, find the quartiles. Part B, find any outliers. So part A is a bit of revision from earlier in the course. So we have 30 females, so 30 numbers, and we're going to find the quartiles. That's the lower quartile and the upper quartile. So the method, and there's more than one method, but this is the main method. For the lower quartile, if you work out n divided by 4, which is 7.5, if that's a decimal, then round up, and that tells you the position of the lower quartile. This is what we do when we've got the raw data in front of us, and we can see we do it. It's not in groups. We've got all the raw data here. So the eighth value is the lower quartile. So 1, 2, 3, 4, 5, 6, 7. I get 3.2 is the lower quartile. So Q1 is 3.2. Now for the upper quartile, work out 3/4 of n, which is 22.5. If that gave us a whole number, then we'd add a half and then look for the value in that position. But once again, like earlier, if it's a decimal, then always round up. This was covered earlier in the course, finding quartiles of raw data. So 23rd value will be the upper quartile. Q3 is the upper quartile. Q2 is the median, which we don't actually need here. Q3 is the upper quartile. So 23rd value, rather than start at the beginning or even start at 8th and count up, I'm going to start at the end and count backwards. Should get there quicker. So 30th, 29th, 28th, 7th, 6th, 5, 4, 3. So 23rd there is 4.0. Don't leave off the 0. It's important. It's different to being just 4.0. And then the units in both cases are this thing that you don't need to understand. You could just copy it out. And that's part A. Right, in part B, we're now going to find, are there any outliers? So the rule we've been given here is that anything lower than 1.5 times the interquartile range, or below the upper quartile, or 1.5 interquartile ranges above the upper quartile counts as an outlier. So we need to find what is the interquartile range, which is always the upper quartile, take away the lower quartile. So that's 4.0, take away 3.2, which is 0.8. Now the upper quartile plus 1.5 times interquartile range is 4.0 plus 1.5 times 0.8, which is 5.2. So any number bigger than that counts as an outlier. Let's find the other limit now. Anything lower than the lower quartile, take away 1.5 interquartile ranges, which is 3.2, take away 1.5 times 0.8, which is 2. So that's the lower limit. So anything less than 2 or anything bigger than 5.2 counts as an outlier. So the upper limit 5.2, there aren't any numbers bigger than 5.2, so there are no upper outliers. However, 1.7 is smaller than 2, so 1.7 is the only outlier. That does not mean we're going to get rid of it. It just means it doesn't really fit the pattern with the rest of the data. It's unusually low. However, unusual things happen all the time. We don't get rid of it unless some reason appears that that value is actually an error. Only then would we get rid of it. So 1.7 is the only outlier.